Mama, हम सुनेंगे. Mama.
Hello, Lanjewar sir. Sir, unmute करा.
हाँ सर, गुड आफ्टरनून.
Good afternoon, sir.
हाँ, आवाज येतोय ना?
हो, येत आहे. माझा येत आहे का नाही?
हो, येत आहे व्यवस्थित येत आहे, काही प्रॉब्लेम नाही.
ओके.
हा.
सर नमस्कार।
हाँ सर नमस्कार.
नमस्ते सर. हे डॉक्टर साहेब नमस्कार.
नमस्कार नमस्कार सर नमस्कार.
कशा आहात?
बस बढ़िया मजेत.
बोरवले सर दिसतात आहे.
Sir,
Very good.
हो
namaskar.
दिसत.
नमस्कार नमस्कार नमस्कार.
Good afternoon to all.
गुड आफ्टरनून सर.
सर आवाज येऊन राहिला का माझा?
हो
हो
येत आहे.
हो. व्हेरी मच ऑडिबल.
येत आहे ना सर? हा, थँक्यू सर. गुड आफ्टरनून सर.
गुड आफ्टरनून. हेलो. तो अभी तक नहीं भरी. एक
Hello.
Hello,
Hello, madam.
good morning.
Yeah, good morning. So, how is the weather is there?
It's very cold.
Oh,
It's winter. Yes, very cold.
okay.
There it's warmer.
In our place now, winter and summer is there. The joint venture is now. Some in the morning cold is there. In the afternoon, hot is there. Yeah.
Okay, no, here it's very cold in the morning. Very, very cold. Yes, about 8 degrees.
Oh,
It's not so bad because in Northern Europe can be 0 or below 0. But
sometimes.
here it is already cold.
Okay, okay. And nice to see you again.
Nice to see you
After-
again too.
Yeah, after a long time. Yeah.
Okay. Thank you for the invitation.
Yeah, no, that's I'm introducing
Should I
our
test?
I'm introducing you, our
Yeah, sorry.
principal. Dr. Badwaik is the principal of our college.
Okay.
Okay, na? Kamla Nehru. Yeah.
Okay, yes,
Hello,
I know.
Badwaik
It's
sir.
no problem.
Madam, good afternoon.
Hello.
How are you, ma'am? How are
Fine,
you?
thank you. How are you?
Very nice to see you on this virtual platform.
Oh, thank you. Nice to see you too.
We welcome you, ma'am, on behalf of Kamla Nehru Mahavidyalaya.
Oh, great. Thank
Madam,
you for the
sir.
invitation.
Madam, sir is the principal of the college, Dr. Badwaik.
Oh, okay.
And
Nice to
another
meet
college
you.
is also there, another jointly organized. Yeah? Another, Dr. Lanjewar is there, principal of the Jagat College.
Oh, okay. Nice to
Oh.
meet you. Hello.
Thank you, madam. Thank you.
Great.
So there is a morning now, na?
Yes, here it's morning. Here it's 9:25 in the morning.
Okay.
Okay, 9:25.
And here is a near about going to 3 o'clock. Okay. Yeah.
Yes, I know. I know.
Here is afternoon.
Yes. Yes, it's 5 hours and a half
Yeah,
different.
yeah. Hello.
Sir, good afternoon. Good afternoon, sir.
Yeah.
Hello, good afternoon.
Hello.
पारे सर जॉईन नाही झाले अजून.
होत आहे सर.
आणि प्रभू
फोन
सर.
केला मी त्यांना.
अच्छा,
फोन केलाय.
प्रभू सर.
प्रभू सर ते ट्रॅव्हलिंग मध्ये आहेत आज.
अच्छा अच्छा,
ते जॉईन होणार नाही.
ओके. Sir, good afternoon.
Good afternoon, sir.
How are you, sir?
I'm fine, sir. Thank you. Thank you.
Every year we are meeting on virtually.
Yes, sir. We should. Rather, more than once we should meet. Yeah.
Right, right.
Thank you, sir.
Sir,
Welcome,
good
sir.
morning. Good afternoon, sir.
Yeah. Good afternoon, Professor Gurnale. Thank you.
Yeah, Dr. Sonia, madam, I joined.
Okay. That's good.
Hello.
Hello, Professor Sonia.
Hello. How are you?
Hello. Yeah, we are fine. How are you, ma'am?
Fine, thank you.
Okay. Thanks. Great.
Thank you for the invitation. It's very nice to be here.
Yeah. Yeah.
I'm really happy.
Most welcome.
Thank you.
चला सुरू करूया.
Yes,
Yes, Mamta,
yes, sir.
you
Yes,
can
sir.
proceed now.
Yes, sir. Yes, sir. I think we should start.
Yeah.
Good afternoon, everyone. A very warm welcome to respected dignitaries and participants for this international webinar on breaking barriers in science, organized by Department of Chemistry, Kamla Nehru College, Nagpur, Association of Chemistry Teachers, and Jagat Arts, Commerce and Science College, Goregaon, Maharashtra State, India, in collaboration with IUPAC Global Women Breakfast. It has been a matter of great pride that Kamla Nehru College has taken a worthy initiative to organize this webinar, as the college has a tradition of holding various conferences, seminars, and academic deliberations on the most relevant topics across all disciplines of human knowledge. The last 4 decades of academics at Kamla Nehru College are full of rich treasure of knowledge across humanities, commerce, science, and management studies. It is the vision of the founder of this institution, late Shri Govindraoji Vanzari, that inspire us to move together to the next best levels of higher education. The testimony of these levels is the NAC accreditation at A+ level recently. Dear all, we in India have a noble tradition of welcoming guests and mark occasions of formal ceremonies by seeking the blessings of the universal power that nourishes the body and soul. We wish to mark this occasion of academic importance by lighting the traditional lamp and cold hand in respect and affection to everyone. We all believe that the light of knowledge leads us from darkness to the world of knowledge and wisdom and purifies the soul to see beyond the narrow boundaries.
कुरुत्वं कल्याणम् आरोग्यं आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Now I request Dr. W.B. Gunule, convener of the international webinar today, to deliver welcome address. Over to you, sir. Gunule, sir.
Sir, unmute yourself. Gurnule sir, unmute. Okay, right.
Good afternoon to all of you. On behalf of ACT and organizing committee, I welcome all the resource persons, academicians, participants for this IUPAC International Webinar on Breaking Barrier in Science, which is organized by Association of Chemistry Teachers, Mumbai, Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur, and Department of Chemistry, Jagat, Arts, Commerce, and IHP Science College, Goregaon, in association with International Union of Pure and Applied Chemistry, Global Women Breakfast 2023. For this program, for this inauguration session, Professor Brijesh Pare, Chief Guest and President of today's inaugural session and President of ACT Mumbai, Honorable Professor D.V. Prabhu, General Secretary of ACT from Wilson College, Mumbai, Dr. N.J. Y. Lanjewar, sir, Principal of Jagat College, Goregaon, Principal of our college, Dr. Badwaik, sir, and dear participants from the globe and from various parts of the country. At first, I would like to make a special mention of Honorable Dr. Vanjari Madam, President of Amar Seva Mandal, Nagpur, and Honorable MLC Advocate Abhijit Vanjari, sir, Secretary of Amar Seva Mandal, and Dr. Smita Vanjari Madam, Treasurer of Amar Seva Mandal, Nagpur. Though they could not join us today, yet their blessings and best wishes are with us. I also extend warm welcome to Honorable Professor Brijesh Pare, President of Association of Chemistry Teachers, Mumbai, for accepting our request to be the Chief Guest and President of this IUPAC GWB 2023 International Webinar. I also extend warm welcome to Professor D.V. Prabhu, sir, General Secretary of ACT, Dr. D.S. Badwaik, sir, Principal of our college, and also Dr. Lanjewar, sir, Principal of Jagat College, Goregaon, by accepting our request to be present for this inauguration session of IUPAC International Webinar GWB 2023. As United Nations had declared 2022 as the International Year of Basic Sciences for Sustainable Development, and it will be celebrated from the 1st July 22 to 13th June 2023. Chemistry is often known as the central science. And having useful link with all other sciences, and especially biology, physics, and other subjects like biophysics, bioinorganic chemistry, engineering, like that, which has made remarkable progress in the last few years. In the last few years, some novel materials have been developed with the interesting properties like here, nanomaterials, superconductors, multifunctional materials. There are many societies of chemistry education which have made tremendous contribution to the science and technology. The backbone for sustainable development is the science and technology. Science and technology are different, but at the same time complementing with each other. So therefore, we can say that material are the solid which can be tailored to develop the desired properties applied for fabrication of devices leading to the societal benefit, and properties are because of being a solid. Therefore, material science, engineering innovations will continue to have an important role as a resource to address sustainable development needs, and perhaps nanomaterial may play an important role. So the main objective of organizing this international webinar is to provide a platform for the interaction and collaboration among the eminent professionals, researchers, and scholars of different fields from academia to discuss and share the state of art development in the breaking barrier in the sciences. This webinar will be definitely beneficial to the participant in their field and young students in particular. IUPAC serve the international scientific endeavor in the dual function of basic sciences and mission-oriented union. The union is a unique position to contribute to the central interdisciplinary chemical sciences, strengthening international chemistry, striving toward the inspiring high standard of excellence and relevance in academic and industrial research, and promoting the service of chemistry to the society and to the global issues. These are the visions that shape IUPAC activities toward the 21st century, and therefore the 2023 IUPAC Global Women Breakfast event will be held on a single day, which is on the 14th February 2023, and the theme of GWB 23 is Breaking Barrier in the Science. And for this international webinar, around 4,200 participants have been registered from different countries like France, Indonesia, Bangladesh, Nigeria, UAE, Malaysia, Egypt, Nepal, Mexico, Oman, South Korea, Canada, Philippines, Saudi Arabia, Hong Kong, Tanzania, and Turkey, and almost all the states of India. So I welcome you all participants on this occasion. We have a great opportunity to be benefited by the talks of Professor Sonia Calabino from the Nova University of Lisbon, Portugal. Another speaker is Dr. Venga Dasaran Balakrishnan from the Power Energy Dedicated Advanced Center from University of Malaya, Kuala Lumpur, Malaysia. And third speaker is the Professor Helen Kavita, Professor and Head Department of Chemistry, SRM Institute of Science and Technology, Chennai, India. So again, at last, as the convener of this international webinar, I welcome all the resource persons, speakers, academicians, and all the dear participants from the globe and India. So thank you and welcome you all. Thank you. Over to you, madam.
Thank you so much, sir. As we all know, good institutions flourish and earn the best titles only because of good leaders at the front. Dr. D.S. Badwai, Principal, Kamla Nehru College, is the man behind these academic arrangements. He inspires all his co-workers to come up with the finest topics and makes them happen. I request Dr. Badwai to deliver introductory remark to this webinar. Over to you, Badwai, sir.
Thank you, Mamta ma'am, for kind words. Good afternoon, one and all. First, I pay tributes to visionary leader, let's say Govindraoji Vandari, founder president of Amar Seva Mandal, who had planted a sapling 39 years before that has become a banyan tree in form of Kamla Nehru Mahavidyalaya, Nagpur. On behalf of Kamla Nehru Mahavidyalaya, I, Dr. Dilip Badwai, principal of the college, extend a warm welcome to all the respected guests, research scholars, participants, and faculty members on the occasion of inaugural function of International Webinar on Breaking Barriers in Science, organized by Department of Chemistry, Kamla Nehru Mahavidyalaya, Association of Chemistry Teachers, Mumbai, Jagat Arts, Commerce and Science College, Goregaon, in collaboration with International Union of Pure and Applied Chemistry, GWB. Chairperson and inaugurator, for this inaugural function, none other than Professor Dr. Brijesh Pare sir, President ACT and belonging to Madhav Science Postgraduate College, Ujjain. Dr. D.V. Prabhu sir, General Secretary, could not grace the dais, but he convey his best wishes. Eminent speaker for this international webinar, Professor Sonia Carabinero from Nova University of Lisbon, Portugal. Second speaker, Dr. Venga Balakrishnan, a good friend of mine, from Malaya University, Kuala Lumpur, Malaysia. Third speaker, Professor Helen Kavitha, Head Department of Chemistry, SRM Institute of Science and Technology, Chennai, India. Principal of Jagat College and good friend of mine, Dr. Nilkant Rao Lanje. Convener for this international webinar, Dr. Vasudev Gurnule sir from our college. Co-convener, Dr. Sanjeev Rangdale from Jagat College. All scholars, faculty members and students from all corners of India and abroad. Once again, I welcome you all with my words. Friends, every year, Kamla Nehru Mahavidyalaya organizes seminar, conferences, workshop to make our faculty members acquainted with current development in different areas. Few days before, we have organized Indian Council Social Science Research sponsored National Conference on Innovative Education Practices, Mechanism and Standards for Assuring Quality in Higher Education. On February 17, 3 days after, we are also organizing National Seminar on Environment, Climate Change and Development Strategy. And as I already said, Balkrishnan sir is there. He is belonging to Malaya University. They are organizing 6th International Conference on Clean Energy and Technology 2023. And we are happy to say that our college is one of the co-organizers there. Since last few years, we are organizing various activities in collaboration with Association of Chemistry Teachers. Our patrons, Dr. Suhasini Vanjani ma'am, President Amar Seva Mandal, MLC, Advocate Abhijit Vanjari sir, Secretary Amar Seva Mandal, and Dr. Smita Vanjari ma'am, Treasurer Amar Seva Mandal, our Kamla Nehru Mahavidyalaya, each continue to attain a new height. As a result, our college re-accredited A+ grade in its third cycle of re-accreditation with CGPA 3.503. Our Kamla Nehru Mahavidyalaya offers 9 graduation courses, 22 PG courses, 2 PG diploma, 6 higher learning and research centers that includes physics, chemistry, electronics, English, commerce and computer science. From our research centers, more than 30 students have been awarded PhD degree and around 35 students are registered right now. We are imparting education to around 8,000 students. Friends, Global Women Breakfast is an event that happens or takes place on a single day in the month of February every year in conjunction with United Nations Day of Women and Girls in Science. The aim is to celebrate the accomplishment of women in science, to inspire younger generation to pursue career in science. The theme for Global Women Breakfast 2023 is Breaking Barriers in Science. Women and men from all type of science organization working in all areas of science come together to share breakfast, either virtually or in person. There is need to build a network of both women and men working together to address the barriers and inequality faced by women in sciences. Unfortunately, women make up only 28% of workforce in science, technology, engineering, and mathematics. Thus, men outnumber women, majoring in most of the science and technology field in colleges. This gender gap is particularly high in some of the fastest growing and highest paid job of the future, like computer science, engineering. The IUPAC is in a unique position to serve as a leading organization and global platform where these difficulties and persistent issues can be addressed in a transparent manner. Gender equality is not only a fundamental human right, but a necessary foundation for a peaceful, prosperous, and sustainable work. The Global Women in Science Breakfast provides a forum for communities to form on a local, regional, and international scale to effectively share ideas and strategies for progress. We received overwhelming response. As Dr. Gonole rightly said, more than 4,000 participants have registered for this international webinar. The eminent speaker in this webinar are internationally acclaimed in their expert areas. I hope this conference will definitely add to the participants' knowledge. Let us come together to celebrate the achievements of women in science, to work towards creating a more inclusive and equitable future for all. Wishing great success for this international webinar. Thank you very much. Over to you, Mamta ma'am.
Thank you so much, sir. Professor N.Y. Lanjewar, Principal, Jagat Arts, Commerce and Science College, Goregaon, who has been instrumental in entering into an MOU with Kamla Nehru College, shares the desk today with the dignitaries. And it will be a matter of pleasure to listen a few words from him. I request Professor Lanjewar to deliver his remarks on this occasion. Over to you, Lanjewar, sir.
Thank you, Mamta ma'am. Good afternoon to all of you. I am audible, madam?
Yes, sir. Yes, sir, you are audible.
Good afternoon to all of you. Respected President of our society, Bahujan Hitai Jagat Shikshan Sanstha Gondia, Honorable Sri Jagat Ramji Rangnale, Secretary Honorable Sri Narayan Ravji Ede, Honorable Dr. Smita Vanjari, President, Honorable Advocate Abhijit Vanjari, Secretary, and Honorable Smita Vanjari, Treasurer, Amar Shiva Mandal Nagpur, President of Association of Chemistry Teacher, Honorable Professor Brijesh Pare, General Secretary, Honorable Professor D.V. Prabhu, Wilson College, Mumbai, Principal of Kamla Nehru Mahavidyalaya, my friend Dr. D.S. Badwai, Vice Principal of our college, Dr. S.S. Bhairam sir, Convener of today's GWB 2023 webinar, Dr. Vasudev Gurnule, today's eminent speaker, Professor Sonia Carabinero, New University of Lisbon, Portugal, Dr. Vengateswaran Balakrishnan, UM Power Energy Dedicated Advanced Center, Wisma, R&D University of Malaya, Kuala Lumpur, Malaysia, Professor Helen Kavita, Head Department of Chemistry, SRM, Institute of Science and Technology, Ramapuram Campus, Chennai, Dr. S.T. Nandeswar, Head Department of Chemistry, Dr. G.K. Bhagat, and Dr. S.S. Rangnale, co-convener of this webinar, and anchor of today's program, Dr. Mamta Wag Madam, and all the members associated with ICT, IUPAC, Global Women Breakfast, all the staff of Kamla Nehru Mahavidyalaya, our college, and all the delegates who have joined in this webinar. I would like to take this golden opportunity to exercise my humble privilege as a principal of the college at this auspicious day, 14 February 2023, the day of international webinar on breaking barrier in science, organized by Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur, Association of Chemistry Teacher, and the Department of Chemistry of our college on the eve of celebration of IUPAC breakfast in synchronization with the theme Breaking Barrier in Science. To welcome all the scientists, eminent research scholars, delegates, invitees, friends who join to participate in this webinar from different parts of our country and abroad, emerging to the world of peace and progress. In the summer period, it is an effort of Dr. W.J. Gurnulle of Kamla Nehru College, Dr. D.V. Prabhu and Dr. Brijesh Paresar of ICT and all members of IUPAC Global Women Breakfast as well as Department of Chemistry and other staff of our college and Kamla Nehru College as a team towards the way of great success together with the support and cooperation received from all of you. We had organized UGC-sponsored different national conference in different subjects and different online national webinar also. But this is the first online webinar organized by our college in association with Kamla Nehru Mahavidyalaya and ACT. This webinar is an important milestone in the march of our college towards the academic excellence. I am very happy to receive such type of tremendous response from the different states of India and abroad. I am delighted to inform you that the growth of Jagat Art, Commerce and Indiraben Hariyarbai Patel Science College, Goregaon had its humble beginning in art and science faculties at the time in the year 1992 at Goregaon, a socially and economically backward places in the Gondia district in Maharashtra. Today, the college run UG and PG courses with YCMOU Center and identifies itself as one of the premier education institution of the Rashtra Sant Tukadoji Maharaj, Nagpur University, Nagpur. Our college re-accredited B+ grade by NAC Bangalore. Our college is run by Bahujan Hitai Jagat Shikshan Sanstha Gondia, a pioneering education society in the Gondia and Bhandara district and established in the year 1981 by great visionary Honorable Sri Jagat Ramji Rangdale with pious purpose of leading the socially and economically backward section of society to the light of learning and knowledge. The theme of today's international webinar, Breaking Barrier in Science, is arising to provide a platform for interaction among eminent scientists, professors, researchers, and scholars in the field of chemistry, physics, and other science subjects. Common barriers faced by science educator is disengagement, relevancy, distraction, presentation, rigorous vocabulary, abstract concepts, complex relationships, labs, assessment, work quality, and organization, etc. One of the breaking barriers in science is the lack of gender equity in science. It is not just a problem that affects women, but also impedes a country development. Moreover, when we limit the size of the talent pool by making it harder for girls and women to choose a career in science, we compromise our capacity to solve complex problems. While women represent only about 1/3 of the world research scientists today, that number is sure to increase dramatically if the number of women graduating with degree in the science will increase. Professor Sonia will deliver her lecture on the topic Breaking Barriers with Gold. Dr. Balakrishnan will deliver his lecture on the topic Smart Self-Cleaning Building Glass, and Professor Helen Kavita will deliver her lecture on the topic Fostering Towards and Equal Science. I express my gratitude to Honorable Sri Jagat Ramji Rangdale, President, Honorable Sri N.A. Nede, Secretary of Bahujan Shikshan Sanstha Gondia, Honorable Smita Vanjari, Madam President, and Honorable Abhijit Vanjari, Sir, Secretary of Amar Shiva Mandal, Nagpur, Dr. D.S. Badwaik, Sir, Principal, and Dr. W.B. Gurnule for their constant support for this activity. I extend my wishes to all, one and all associated with this conference. Thank you. Thank you very much, sir.
Thank you so
Over
much,
to
sir.
Mamta, madam.
Thank you so much, sir. The guest speaker for inaugural session, Dr. Prabhu, has conveyed his inability to attend the function personally. However, we are very much thankful for his earlier consent to deliver the address for this webinar. Moving ahead, Professor Brijesh Pare, Chief Guest and President, Association of Chemistry Teachers from Madhav Science PG College, Ujjain, has consented to the chief guest for this webinar. He has 33 years of teaching experience at UG and PG level. He is a recipient of postdoctoral research fellowship from National Research Foundation, Pretoria, South Africa. He has to his credits more than 70 research papers in national and international journals of high repute. 18 research students are awarded doctorates under his academic supervision, and 6 students are currently working under him. He was the member of IUPAC UNESCO in the year 2012-13. He has organized more than 100 workshops for the popularization of chemistry for students and teachers across the world. He is working actively with Royal Australian Chemical Institute and Royal Society of Chemistry, London. He has represented India for the International Australian Chemistry Quiz conducted by Royal Australian Chemical Institute, Australia. His area of research interest is science education, working on novel methods of teaching and learning, phenomenon-based learning, understanding and identifying students' misconception, learning barriers in the concept of chemical bonding, designing and assessing appropriate remedial measures, green technology and advanced oxidation process. With this formal introduction, I most humbly call upon Professor Pare to deliver his address. Over to you, sir.
Thank you. Thank you. Thank you. Thank you, Dr. Mamta Wag. I am audible?
Yes, sir. Yes, sir.
Oh, thank you. Very good evening to all of you. Mr. Principal of the college, Dr. Dilip, my very good friend, Professor Gurnale, who is very instrumental in organizing all wonderful seminar. And today is a very important day, from the point of view of IUPAC, UNESCO, because for the last couple of years, IUPAC has been organizing global women breakfast across India. Across the globe and in India, under the aegis of Association of Chemistry Teachers India, we are doing very well in terms of the number of participation. Last 2 years, we were among the first and the second consecutively across the world. And this year, today, not less than 55 colleges and universities in India, they are celebrating this global women breakfast. So I'm really happy. And I congratulate the organizers on behalf of SCT and on my personal behalf that this movement, is gearing up. The aim of this program is to celebrate and to celebrate the accomplishments and the achievements of women in science and in the society, and particularly the STEM career. Men and women, from all types of science organizations are coming together to share the breakfast either virtually or in person. Because 2 years, we did it in the webinar format. It was all pandemic, but this is the year. Most of the organizations.
They have तसंही कॉलेजमध्ये येतात सही करून निघून जायचं ना.
So they are doing it offline as well as online. The central goal, of this program is to establish an active network of both men and women to increase diversity in all aspects of science. And diversity is very important. Diversity is essential to delivering excellence in science, technology, engineering, and mathematics. STEAM. A diverse and inclusive scientific workforce draws from the widest range of backgrounds, different perspectives, and experiences. They maximize the innovation and creativity in science for the benefit of humanity. So this is the core point, that is the diversity and the inclusive group of the people for deliberation and for the betterment of the society. Global this breakfast this facilitates the formation of communities on of course the local level, regional level, and on the international scale, to effectively share the ideas and strategies for problem. What we are doing, the different programs, we are getting different speakers, and we are trying to work effectively on important ideas. Sorry. I will take not much time, but I wish to speak, some of the things, from past, and just try to look on it, that how much as a society, and from the viewpoint of the status and position of women, we have traveled in the field of science. So, you might have seen, the books from science and history, they are just full of lot of mentions of great men, the contribution from the great men, and many of whom, of course, not that great. And many incredible women who have created history, those who have contributed in the field of science, have been simply just written off, and many a time because some man, was there to take the credit of her work. I will just go through some of the, very simple, beautiful stories. You just might be, we all know about the Rosalind Franklin. We know about the double helix structure of DNA. So, and we know the people, 2% the James Watson and the Francis Crick from the Cambridge University. They have been credited for the discovering the double helix strand structure of the DNA, which pushed toward our understanding of the human DNA to a great extent. However, let me tell you, it was the British chemist, a lady, an X-ray crystallographer, Rosalind Franklin, who produced the one groundbreaking image, Photo 51. It's a very popular photograph, X-ray diffraction photograph, Photo 51, we call it, which she was engaged in his research at the King's College London somewhere around 1951, when she produced this groundbreaking image, Photo 51, that is a X-ray diffraction photograph of DNA. What happened, one of her colleagues showed image to the male scientists, these two, like this Crick and Francis, without telling Franklin. Franklin was not informed that this image had been shown to these two gentlemen. It took Franklin a year more to fully interpret and describe the double helix structure. Now what happened, 2 years later, Watson and Crick published their findings somewhere in 1953. Franklin was published in the same journal, but in the later pages, which gave people the idea that her work supported that of the other two. See, the lady worked originally, Franklin, but the Watson and Crick got the credit for that. A year later, and very unfortunately, Rosalind Franklin died of ovarian cancer. And 4 years later, these two gentlemen, Watson and Crick, they got the Nobel Prize in 1958 for the double helix discovery. So this was a kind of, a very unjust kind of thing. And apart from this work, this Rosalind Franklin, she unraveled the structure and the porosity of coal for her PhD thesis, which led to the British to develop the better gas mask during the World War II. And also Rosalind worked on RNA, and the viruses supported chemistry Nobel Prize, got some another fellow, Aaron Klug, and for creating the 3D images. This is one example. This is one example how the society was that, the lady was working and the society was not ready to give any attention to the work from a lady. The work was discredited, and the other people, there's no point, it's mentioned in the history, the other people, and of course, men got the Nobel Prize and the recognition. One more example I will just talk about. This is the International Year of Basic Sciences for Sustainable Development. We everywhere, we are talking globally about the sustainable development. Let me tell you about one small story. We all know Tyndall, John Tyndall, a British scientist. He is most often credited for discovering the greenhouse effect. Greenhouse effect, the gradual warming of Earth's atmosphere, which is a foundational discovery in the field of climate science. Climate science. That is what I'm taking this example. But you see, it was Eunice Foote, a pioneer American scientist and a women's rights activist, who first theorized and demonstrated the greenhouse effect. This was again an experiment, the original experiment carried out by a woman. She conducted a series of experiments in 1950s, where she filled glass cylinders with different gases and kept them in the sun, under the sun, to measure how the temperature changes differ. Eunice Foote, found that the sun's rays were warmer when passing through moist air rather than the dry air, and the warmest when passing through the carbon dioxide than any other gas. So this was a wonderful, a simple experiment and very basic experiment. She did publish her findings in the American Journal of Science in 1857, but she was not even allowed to present her research at a scientific conference and had to ask a male colleague to do it. This was the situation in 1857. And though her work was published 3 years before Tyndall, it is the male scientist that most popular remember for discovering the greenhouse effect. So, these are the examples, and this was the situation, and this was the disparity and kind of inequality. But now, what I wish to tell, that we have traversed a lot of distance. We have traveled a lot now. And now, of course, still, the society has to improve in terms of the equality towards the woman, but now we have traveled a lot. I think this is my point of view. And again, at this stage, I congratulate the organizers for giving me this opportunity. Association of Chemistry Teachers India has been working for the last 23 years in India for popularizing chemistry particularly, and we are almost 3,000 in number, and the members are from various colleges and universities and industry in India. And we have a mandate of popularizing chemistry in India. So we are doing it. Thank you very much. And once again, I congratulate the principal and Professor Gurnale for having given me this opportunity. And I wish that all our speakers will deliberate, and your students and the young generation will be benefited. Thank you very much.
Thank you.
Thank you very much, sir. Thank you very much, sir, for such an informative talk. Due to some prior occupations, Madam Smita Vanzari has conveyed her apology for her absence for the proceeding of this webinar. However, we at Kamla Nehru College are always supported and inspired by her. At this moment, inaugural session of this webinar stands over, but before we break and meet for the technical sessions scheduled shortly, I request Dr. Rahangdale to propose a formal vote of thanks to the inaugural session of this webinar. Over to you, sir.
Thank you, madam. Am I audible, madam?
Yes, sir.
Good afternoon to one and all. IUPAC International Webinar or Breaking Barrier in Science, GWB 2023, organized by Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur, Jagat Art, Commerce and IHP Science College, Goregaon, and Association of Chemistry Teachers, Mumbai, in collaboration with International Union of Pure and Applied Chemistry, Global Women's Breakfast 2023. First of all, I would like to vote of thanks Honorable Dr. Suhasini Vanjari Madam, President Amar Seva Dal Mandal Nagpur, Honorable Advocate Abhijit Vanjari, MLC and Secretary Amar Seva Dal Mandal Nagpur, Honorable Sri Jagat Ramji Rangdale, President Bahujan Hita Jagat Shikshan Sanstha Gondia, Honorable Narayan Ede, Secretary Bahujan Hita Shikshan Sanstha Gondia, Honorable Dr. Smita Vanjari, Treasurer Amar Seva Mandal Nagpur. They always have been a source of inspiration for us, though they could not join, but their blessings are with us. I am thankful to Honorable Professor Dr. Brijesh Paresar, President ACT Madhav Science Postgraduate College, Ujjain, who shared her valuable thought with us in his presidential address. I would like to thank Dr. D.S. Badwaik Sir, Principal, Kamla Nehru College, Nagpur, for his introductory remarks on today's webinar. Thank you, sir. I am also expressing my sincere thanks to our principal, Professor Dr. N.Y. Lanjewar, Jagat Art, Commerce and IHP Science College, Goregaon, for a speech in the inaugural session of today's webinar. I am also thankful to Professor Dr. W.B. Gunule, convener of International Webinar, for the welcome address. I am personally and on behalf of organizing committee thankful to the resource person, Professor Sonia Ma'am, New University of Lisbon, Portugal, Dr. Balakrishnan, Power Energy Medical Advancement Center, Wisma R&D, University of Malaya, Kuala Lumpur, Malaysia, Professor Helen Kavita, SRM Institute of Science and Technology, Ramapuram Campus, Chennai, India. I am also thankful to all the participants from various states of India and also from 13 different countries like Bangladesh, Indonesia, Nigeria, Portugal, Malaysia, UAE, Egypt, Nepal, Oman, South Korea, Canada, Hong Kong, Zimbabwe, like these countries, for giving warm response of international webinar. Also, the staff members of organizing institute also need to thank, because they did not leave in earn to make the conference a grand success. At last, I give thanks all those who help us directly or indirectly to make this international webinar a grand success. Once again, I express my hearty thanks to one and all. Thank you very much, ma'am.
Thank you very much, sir. Now it's time for the technical session. So I hand over the further proceeding to Dr. Rashmi Dubey, Assistant Professor, Department of Chemistry, Kamla Nehru College. Over to you, Rashmi.
Am I audible, ma'am?
Yes, Rashmi.
Thank you so much, ma'am. Good afternoon, one and all. Now, let us move with the technical sessions. And it's my pleasure to invite today's first speaker, Professor Sonia Carabinero. She is graduate in Applied Chemistry from New University of Lisbon, Portugal, and obtained her PhD degree in Chemical Engineering in 2001 from the same university. She was postdoctorate researcher from 2001 to 2003 at Leiden University, the Netherlands, and from researcher 2004 to 2007 at University of Lisbon, Portugal. From 2007 to 13, she was assistant researcher at University of Porto, Portugal, and principal researcher from 2013 to 2018. In 2019, she was invited professor in the Wuhan Textile University, China, and integrated researcher at the University of Lisbon. She obtained habilitation in chemistry at the same university. In 2020, she became an assistant professor at New University of Lisbon. She is co-author of more than 20 chapters in book, more than 200 articles in international scientific journals, and more than 200 communications to national as well as international conferences. She has total 15 invited talks. She is co-inviter of one worldwide patent, evaluator of several international project proposals, and she has more than 1,700 citations. She is a regular referee of several international journals, being currently one of the top female reviewer in the world. She is also a member of editorial and revival board of several journals, including ChemCat, Scientific Reporters, Nanomaterials, Catalyst, etc. Today, she is going to deliver her topic on breaking barriers with gold. So I request Sonia ma'am to start her session. It's over to you, ma'am.
Thank you very much, Dr. Hashmi. So I'm going to share my screen. Okay.
Yes,
So
ma'am.
good afternoon, everybody. I'm going to talk about breaking barriers with gold. Gold is a very nice catalyst, as we will see. I thank the opportunity to be here speaking to you, and I thank the invitation from the organizers. Okay, seeing the world map, you see Portugal is this very, very small country here at this side of Europe. So this is the Nova University of Lisbon, the Faculty of Science and Technology. It's close to the Atlantic Ocean. So this here is the campus, and you are very welcome to visit me there. Well, we all know, we chemists know that a chemical reaction takes place like this. We have A and B, for example, we want it to get together to form C. But for A and B to get together and form C, it takes some time. And not just that, there is a barrier that is called the activation energy that needs to be overcome. So how to break this energy barrier? We use a catalyst quite often, and the catalyst links to A and B, forms C, and C is released, the catalyst is left unharmed. So is this a good alternative? Well, it is, because this barrier, this activation energy, decreases a lot, so the reaction can go like that. So examples of catalysts are, for example, soluble catalysts like these gold 1 and gold 3 complexes. They are homogeneous, they are in solution, we cannot really see them, and it's hard to separate. But there are also the heterogeneous catalysts, and some of my favorites are, of course, metal nanoparticles, gold mostly. And here we have some examples of gold nanoparticles supported on oxide supports. So here we have titanium dioxide, it's white. If we support gold, it becomes this, it has this nice purple color. And here we see the gold nanoparticles on a transmission electron microscopy image. Also zinc oxide, this zinc was prepared by chemical vapor deposition in collaboration with a group from France. And if we deposit gold, again, it becomes purple, and these tetrapods here, we can see one of them of zinc oxide, and the nanoparticles are well deposited on it. It's quite nice. Well, gold in the old days has been in the mind of alchemists. We see an alchemist here, but they thought gold was only a noble metal. They didn't realize it could be good for catalysis. And the reason why is that platinum group metals like platinum and palladium and rhodium, they exhibit both high chemabsorption power and also high catalytic activity for several reactions. But as gold had a low chemabsorption ability, it was wrongly believed that it had a low catalytic power as well. So gold was ignored from catalysis. However, in 1906, the first report of a catalytic use of gold for hydrogen oxidation occurred. So here we have the paper in Philosophical Transactions, and they used this apparatus. So this was a barrier that gold was breaking back then. 1925, the first reference of gold as a catalyst for CO oxidation. So we have it here, another barrier breaking. And in 1972, the first review paper dealing already with the potential industrial applications of gold. So again, this was also a barrier being broken. In the last 30 years, there has been a large increase in the field, especially due to the work of these three gentlemen, Masataka Aruta from Japan, Geoffrey Braun from United Kingdom, and Graham Graham Hutchings. Sadly, these first two were deceased last year, so a great loss. And gold is now accepted so widely as a catalyst that there has been already 9 conferences exclusively dealing with catalysis by gold. So you see them here. It started first in Germany, then it spread all over the world, and the latest one was here last year in Quebec, Canada. We may ask, but why took it so long to discover that gold could be active, that gold could be a good catalyst? Why took so long for this barrier to be broken? Well, the reason is that gold is only active in the form of nanoparticles well dispersed on the support. So that was the reason. And crucial factors affecting activity are the nanoparticle size, the reducibility of the support, and the interaction of the support with gold. So here we see gold on cerium oxide. See here the gold nanoparticles. They are very small, from 2 to 5 nanometers, and they are prepared by a double impregnation method that I will explain in the next slide what it is. So these are active gold nanoparticles. However, if we prepare by impregnation, that's a method commonly used for platinum group metals, and it works well for those metals. If we use it with gold, we obtain very large gold nanoparticles. See here, about 400 nanometers size, and those are inactive. Only the small ones are active. The reason is that chloride, present in most gold precursors, causes sinterization of the gold nanoparticles, especially at higher temperatures, and then making them inactive. So it's very good, crucial to remove the chloride from these catalysts. We can do this by using a gold precursor that doesn't contain chloride, but these are more expensive, more hard to find. Or else we do other methods so that we can remove the chloride. And therefore, a careful preparation of gold catalysts is needed. For platinum group metals, it's much easier with just impregnation. Therefore, some gold loading methods for gold or other metals can be used. We have here deposition precipitation. For example, the pH of the gold precursor solution, usually it's this HAUCl4, is raised until 9 or 10, depends, with sodium hydroxide or urea before the addition of the support. Then we let it be there, we filtrate, we wash and dry, etc. There is also another method, liquid phase reductive deposition, for example, and the precursor is mixed with solution of sodium hydroxide and aged for 24 hours in the dark before being impregnated into the support. And again, washing, drying, etc. And there is the double impregnation that I spoke in the previous slide, that it's the previous impregnation with the gold precursor and the further second step of impregnation with sodium carbonate. So these are all methods to remove the chloride away by washing. And there are several examples of reaction efficiently catalyzed by gold. So we see several oxidation reactions, oxidation of many substrates, and also reductions, etc. So I'm going to talk about some of them today, mostly dealt with environmental catalysis. And you see here now there is a lot of publications dealing with catalysis by gold. See, not only catalysis by gold, but also gold in chemistry, biology. See here, gold nanoparticles for cancer treatment, for nanomedicine. So gold is all over in many applications. And the first reviews on gold catalysis with the Portuguese affiliation were written by me and by Dr. David Thompson, also already deceased in 2009. And also more recent reviews I've been writing on gold. So you can see here some examples these are book chapters. I also have other articles, but I am very, very enthusiastic about catalysis by gold. And one of the features of gold is that it can be used namely for CO oxidation, which is this reaction, CO plus oxygen to give a CO2. And gold is already active between -70 to +70 degrees. So you can do this reaction at very low temperatures, even in the North Pole and room temperature there. And platinum group metals like platinum and palladium, etc., are only active above 100 degrees Celsius. So this is very good to use gold in this reaction at lower temperatures. Also for the water-gas shift, which is mostly the same reaction as CO oxidation, but in the presence of water, and then hydrogen is also formed. You see here a comparison of a gold catalyst with copper and platinum catalysts. We see that gold is already active at 100 degrees, while others are active at higher temperatures. So this is just an example. This reaction is very important to produce hydrogen for fuel cells. And if we have hydrogen generated from a carbon-containing source, like for example, methane, what happens is this. We produce hydrogen and also produce CO2. And this first reaction is no problem because CO2 does not affect the fuel cells. However, there is this production of 0.5% CO. And you might ask if this is a problem because it's very low percentage. And in fact, it is because above 0.01% CO, the platinum proton exchange membrane fuel cells are poisoned. So we could not have CO in the stream. Its elimination is very crucial. So we already saw that gold is very active for this reaction. It transforms CO into CO2. So that's good because CO2 does not harm the fuel cells. However, platinum is also very active for this reaction. It can also do that, well, except at lower temperatures, of course, but it can do as well. However, the problem is that platinum oxidizes everything. So it also oxidizes the hydrogen that we are trying to produce. This is bad. So the advantage of gold is that it's more selective than platinum and other platinum group metals in the oxidation of CO in the presence of hydrogen, the so-called preferential oxidation. Moreover, gold is nearly insensitive to CO2 and its activity is even enhanced by water. It can be enhanced up to 10 times more in the presence of water. Therefore, gold catalysts are very good candidates for hydrogen production and purification, this type of reactions, which is very good. About this CO oxidation reaction, well, it's a simple reaction. It has been very well studied, but it's still poorly understood, and it's often used as a model reaction for gold catalysts. But this reaction is very important in pollution control, air purification devices, cleaning of automotive exhaust gases, like in this image, also in fuel cells and gas sensing. And we already saw that gold catalysts have advantages for this reaction because they have good activity at low temperatures and are stable in the presence of water. And the CO oxidation on gold takes place by the so-called Bond and Thomson mechanism that was proposed in the year 2000 and later was confirmed by the results of other authors, is that the mechanism is similar to a Mars-Van Crevelen type of mechanism. That is, the CO is oxidized by the oxygen from the oxide support, not really from the oxygen that we are supplying. So the oxygen supplied is only used to replenish the oxide surface. So this is the mechanism that takes place. Here some examples of work of mine on CO oxidation reaction on gold supported on metal oxides. So we have here several metal oxides, copper and titanium, nickel oxide, etc. And we see here some results at room temperature, and we see this double impregnation method was the most active compared to a liquid phase reductive deposition, and also much active than the similar catalysts on gold on nickel oxide from literature from that time. And we see here that the range, the gold range, this one here on nickel oxide was a bit smaller than the others. So we thought it was that was the reason, and also the good reducibility of nickel oxide. So we see here on this sample that at 25 degrees it's almost total conversion, and then here at 50 degrees we have full conversion, while the other methods and no catalysts are not able to do this except at higher temperatures. And you might ask, but didn't you say it was very active already below room temperature? Why you need 25, 50 degrees? Well, the reason is that we are using 5% CO, and the other experiments used about 1% or less CO. That's most common in literature. We used very high amount of CO, but even so, you see here, per mole of CO, our catalyst is much better. And we have here an example for another reaction. For example, nitrous oxide, for a long time, it was not considered a pollutant species, but it is a very powerful greenhouse gas that has a global warming potential very high, 300 times higher than CO2. And it has a long lifetime in the atmosphere, around 150 years. So you see, we have here greenhouse effect, natural greenhouse effect. The solar radiation comes to Earth, but it can escape into space. However, if it's intensified by humans, we have all these greenhouse gases there, and the solar radiation cannot escape through space. So there is the global warming. And also it has an ozone layer deplexing potential similar to that of fluorofluorocarbons. And it has been increasing 15% increase in the past 200 years. And this reaction, the decomposition of N2O on nitrogen and oxygen, only occurs at very high temperature. So the direct catalytic decomposition would have advantages because it's efficient, simple, and requires low energy. So we use these catalysts here, gold on several metal oxides, prepared by deposition precipitation to this reaction. And we did here first hydrogen temperature program reduction to see how reducible they were. And see here in aluminum with or without gold, no reduction. Here with zinc, only hydroxylation. Here with titanium, only the gold was being reduced. But on cerium oxide, here without gold, we see the surface oxygen being reduced, and here the bulk oxygen. When we add gold, this peak of the surface oxygen is shifted to lower temperatures, so it's much more reducible when gold is present. So we see it here, the bulk oxygen is left unharmed. And if we have here the reducibility of iron oxide, so this peak here is the reduction from Fe2O3 to Fe3O4, here F3O4 to FeO, and this one from FeO to iron. And if we add gold, these peaks are also shifted to lower temperature, means that is easier, more easily reducible. And if we do the N2O conversion using gold on oxide catalysts, we have here with gold, and we have without gold. So these ones are without gold, the darker ones are with gold. And what we see here is that there is this catalytic performance order. So iron oxide is much better than cerium oxide, better than zinc, than titanium, and aluminum oxides. However, if we add gold, it increases the catalytic activity, indeed, but the order is maintained. There is iron on gold better than iron on cerium, etc. So we see that the activity is not only related with gold nanoparticle size, because the size is very similar here, you see here, and this one is even lower, but it doesn't do much difference. But what is here more present is the reducibility of the support. It's the key factor. We are seeing this. As we saw, the iron oxide was very easily reducible, and also the cerium oxide with gold. Another example of a gas that is greenhouse gas present in the Earth's atmosphere is CO2, carbon dioxide. And its concentration keeps increasing. It was 280 ppm in pre-industrial times. Now it's around 400 ppm and is expected to be 570 ppm by the end of the century if appropriated mitigation actions are not implemented. So we hope they are. Those mitigation actions would be to reduce the rate of CO2 emissions. That is a very good goal. Also to capture and store anthropogenic CO2, and to use the atmospheric or industrial CO2 to produce useful chemicals and fuels. So for that purpose, we use CO2 hydrogenation using gold on oxide catalyst. This was done in collaboration with the Greek group, just like the N2O experiments. And our aim was to produce methanol. What we see here is that the zinc oxide is the only oxide without gold. So we have here the oxides and the oxides with gold. And methanol is not produced by any oxide without gold except zinc oxide is the only one. And we also see that gold on alumina is the worst catalyst because it's not able to produce methane. However, gold on cerium oxide is the most active catalyst. It's here. And if we test its stability, it's very stable up to 48 hours. You see here, the CO2 consumption and the methanol formation is very, very stable. So we see this because cerium oxide is also very easily reducible, as we saw with the temperature programmed reduction experiments. Other examples are volatile organic compounds that are emitted from industrial processes and transportation. They have major contributions to air pollution. They are toxic, malodorous, and involved in the ozone depletion layer, and involved also in smoke formation. Some examples of volatile organic compounds are ethanol, toluene, ethyl acetate. They are present in these chemicals in all over. The thermal oxidation of VOX operates at very high temperatures, above 700 degrees Celsius, and leads to NOx production from the nitrogen from air. So it's bad. The catalytic oxidation of VOX, it's much better because it operates at lower temperatures, so it produces less NOx and also less energy is needed. So it is a good. There is a Mars van Krevelen type of mechanism that occurs. So the VOC passes here, and it's the oxygen from the support that oxidizes the VOC. And the oxygen supplied, you see, it's only used to replenish the surface. Like this, it goes away, yes, and the oxygen is used to replenish the surface. So we are back to the original. It's a cycle. So this oxygen that we are supplying, it's not oxidizing the VOC. It's just replenishing the surface because it's the oxide from the surface that is oxidizing the VOC. So the role of gold is only to enhance the reducibility and reactive of the oxide surface and increase the exchange rate between lattice and surface oxygen. And as we saw with the cerium oxide, when we add gold, the reduction peak shifts to very lower, much lower temperatures from 500 to 100. So it's quite good. And we have here some example on the oxidation of box. Here on gold on exotemplated oxides. They were prepared by an exotemplated method. And we see here for the oxidation of ethyl acetate. So here are two samples of ceria only. You see here that ceria alone is not able to fully degrade the VOC. This would be 100% conversion, so the maximum is around 90% conversion, even at 400 degrees. If we add gold to these samples, you see here that the conversion takes place. It's much more active at lower temperatures, and the conversion is full conversion obtained, you see here, at around 240 degrees. So this is for gold on ceria for ethyl acetate. And if we see here an example for oxidation of ethanol, the same. If we have ceria only, we cannot achieve full conversion, and we need higher temperatures to achieve around 90. And if we add gold, again, it is able to get full conversion. If we have the oxidation of toluene, toluene is the most difficult VOC to oxidize, so it needs higher temperatures. You see here, no full conversion is obtained, and with gold, we obtain it at much lower temperatures, of course. But if we have manganese oxide, which is much more reducible than ceria, then for the oxidation of ethyl acetate, we have here quite a large difference. It's much more active at lower temperatures and, again, full conversion. So these are just some examples. And the gold size, you see here, it's a little smaller here than in the other cases. Also, this example here, yttrium oxide, it's not very common oxide. You see here, it doesn't convert, almost no conversion, maximum conversion of 40% at 400 degrees, it's very low. If we add gold, we can achieve a higher conversion and full conversion. Of course, the temperature is higher than with manganese, but we are only testing catalysts that are not usually active. So here, for toluene, it's almost no activity, and with gold, it can improve a lot. And also, here, magnesium oxide, you see here, without gold, impossible, here, much. And also here, you see this is a remarkable difference. So only 70%. If we add gold, we have at much lower temperature this conversion. And we see the size is very similar, so it is related with, it's not related with the size of gold nanoparticles, yet with the support. Therefore, some conclusions on this. Well, I have many other reactions that I tested with gold, alkanes, alcohols, etc., but of course, no time to talk about everything. We see that gold nanoparticles are good catalysts for several different types of reactions. These were just some examples I showed for environmental reaction, causing them to occur at much lower temperatures than without a catalyst. Of course, the small gold nanoparticle size, although very important, is not able to explain everything, because catalytic activity also depends on several other factors, like the nature of the support, the reducibility mostly of the support, and the interaction of the support with gold. So I think gold catalysts have a golden future. Some acknowledgements for funding, etc. And I just, as we are on Global Women's Breakfast, I just want to show this article that was in Nature, published in Nature in 2018, saying that leading journals lack female authors. So it is very, very sad. And as the professor, the other professor was saying, indeed, well, sometimes in the past, gold, not with gold catalysis, but with other types of research, sometimes it's women don't have the credit of their research. We hope this is changing now. We are much better now, but still a long way to go. So leading journals still lack female authors, so I want to encourage all female authors to write good good papers to submit to several journals. And due to that, well, I am showing you some special issues from which I am guest editor that we are requesting a call from for papers. So here we have catalysts, call for papers for graphene-related materials for catalytic applications. I'm one of the guest editors with these two professors, Professor Lu and Professor Zhu from China. And also this other special issue leading with catalysis in dual carbon targets. So for catalysts, graphene-related materials and dual carbon targets. And also for processes, I'm guest editor of this special issue on advances in supported nanoparticle catalysts, volume 2, because I was already guest editor of one special issue with this name. So if you have research on supported nanoparticle catalysts, please submit to this special issue, and also to this special one on nanomaterials, composite materials for environmentally important processes. This nanomaterials has a very good impact factor that has been rising. So please submit. Also, I have to say that journals invite too few women to referee. You see here, this was on Nature, also on Nature on 2017. They realized that very few women were invited to referee. And we see here, both male and female authors suggest fewer female reviewers than expected on the basis of publication rates. So please, let's suggest female referees. And also editors, especially male ones, it is said on this article, that they invite too few women to referee. And if you see here, male and female reviewers, male were about 80% and female only 20% in 2017. So let's change that. I'm one of the top female referees in the world. I was first place, now I'm second in the world. But of course, there are other men that have much more referees than me. So only among the women, I am second now. So I am a member of the editorial and advisory board of several journals, and I am calling for referees. So if you women or men want to be referees of some of these journals, I can suggest your names. Well, send me an email saying which topics you would like to be a referee on, and I can suggest you when there is a paper and we need referees. So CAM, Frontiers, Catalysis Today, Nanomaterials, Catalysts, or scientific reports. I'm often editor of scientific reports. I need to find reviewers, so please send me your email name and email and affiliation and what you would like to, what kind of papers you would write to referee, and I can suggest you. So that we can overcome this barrier, not just for women, but also on the other minorities and other people. So the idea is to have equal gender and equal opportunities for everybody. So I also invite you to visit Portugal. So you see, you will find very nice places to visit in Lisbon, the capital, Porto, Coimbra. This is South, Algarve and Sintra, lots of very nice castles, very nice things to see. Also, what a good way to break barriers than with a good lunch. This is the female breakfast, global female breakfast lunch, but also this is more lunch, not breakfast. Although in India, I know in the morning you eat a very large meal. It's very good. So this is typical dishes from Portugal. I am sure you will love it. And also to meet the traditional Portuguese song that is the Fado, that is now UNESCO Intangible Cultural Heritage of Humanity. So thank you for your attention.
Thank you very much, ma'am. Thank you very much for this informative session. And definitely there is a great difference in the percentage of the male and the female reviewer.
Yes.
Thank you so much, ma'am. Thank you. If from participants, if anybody have any question to ask, they may ask their question or put your question in the chat box.
One. Okay. Hello, Dr. Sonia. You are giving very nice and wonderful presentation on breaking
Thank
barrier
you.
on the gold. Okay. And thank you for your nice presentation. Just I want to know what you mean by this cytotoxicity when we relate with the nano gold particles. Just I want to know, yeah.
I think you are referring to Dr. Zuber's question.
Yeah,
It's
yeah.
on the chat. What about other nanoparticles? Is there any future for them? Yes, I think so. Well, the reason that I chose gold is because I've been working on gold for several years. But of course, I know gold is a noble metal and noble metals are scarce and so on. But of course, we can always recover gold afterwards. We can get rid of the support and recover the gold. So it's not so much of a problem. But of course, if you can get other types of nanoparticles, like for example, copper nanoparticles, are much less expensive. Of course, if you can get them to be as active as gold is, then even much better, of course. I think other nanoparticles, other catalysts, noble metal-free catalysts, I also have some research on them, indeed. So, of course, they also have a golden future.
Okay, yeah. Okay, thank you.
Thank you.
And hello, madam, one more thing is that you are working on the catalysis now. Gold is a very nice and noble metal and oxides are and can be used catalyst. Various applications are there. Okay, now. So just I want to know what are the disadvantages when we deal with the gold nanoparticles? What are the disadvantages of catalysis?
Well, depends on the reactions. Because as you saw, for example, for CO oxidation, the advantage is that it can be used at low temperatures. Oh, let me just share the screen again. See, it can be used here. You see, gold is very active at lower temperatures for CO oxidation, so this is an advantage. Also here, gold is it's much more selective than platinum in the presence of hydrogen, so it doesn't oxidize the hydrogen. It only oxidizes the CO. Its activity is enhanced by water. It's insensitive to CO2. So these are some of the advantages, of course. Also here on the VOC oxidation, you see, it allows to be done at lower temperatures. So I would say these are some of the advantages, and depends on the reactions. Other reactions also gold has advantages. For example, in homogeneous reactions, I did not talk about them today, but there are some reactions that are catalyzed by gold that cannot be catalyzed by hardly by any other metal. So it's a lot of advantages everywhere.
Okay. Okay, thank you.
Thank you.
Okay, over to Rashmi.
Yes, thank you so much, ma'am. Thank you very much for this informative session.
Thank you.
Now, let us move towards our second session. Our next speaker is Dr. Balakrishnan from Power Energy Dedicated Advanced Center, WISMA, R&D University of Malaya, Kuala Lumpur, Malaysia. He has a long research service experience in nanosynthesis, hybrid organic coating, heat resistance coating, self-cleaning, hydrophobic coating, and solar panel industries. He has 14 years of research experience in research centers such as NanoCat and CIUM. He published 60 technical papers in national as well as international journals and conferences proceedings. He published 10 book chapters and chief guest editor for pigment and resins technology. His research area are nanoparticle synthesis, nanoparticle characterization, synthesis of composite organic coating for corrosion prevention, synthesis of self-cleaning hydrophobic coating, etc. He has some ongoing projects also on fundamental study of protection and degradation mechanism of polymeric coating for corrosion prevention, as well as high-performing flexible thin polymer electrolytes for safer and more sustainable electrical appliances. So I invite Dr. Balakrishnan sir to start his session. Over to you, sir.
Yeah. Am I audible?
Yes, sir.
Okay, very good. Thank you so much, madam. Thank you so much. I would like to express my gratitude to Dr. Gurnole and Dr. Badvik sir to give me an opportunity to share our work and to present my keynote lecture over here. So I'd like to thank everyone over here. Okay, let me share my screen. Okay. Okay. Okay, this is our Wisma R&D, University of Malaya. This is based in Kuala Lumpur. Okay, so I'm from Kuala Lumpur, Malaysia. Okay, and University of Malaya is one of the oldest university in Malaysia, the first university. It was known as National University of Singapore when Singapore was together with us. And when Singapore has departed from Malaysia and it has been transformed into University of Malaya. And that is University of Malaya is one of the pioneer university, the oldest first university in Malaysia. Okay, and this is our research area, basically in University of Malaya Power Energy Dedicated Center. Okay, our research area is mainly focused on smart grid, solar panels, solar systems, PV modules. We do how to go to grid. Okay, so we have done our own solar panels where we support to the smart grids over here. And apart from that also, we are doing research on electrifications, like zero CO2 on residential, zero CO2 on commercial, zero CO2 on transportations, and zero CO2 on industries. Okay, so these are the transformations which we are doing at the moment. Okay, and apart from that, we are also doing what we call hydrogen fuels and EV. Now we are talking about EV. Now we are doing, we are gone into EVs, electric vehicles as well. Okay. So this is a small introduction about our center. So today's talk is about smart self-cleaning building glass. Okay. So, and over here, okay, you can hear me, right? Yeah, I'm audible, right?
Yes, yes.
Yes, okay. So now the project description is mostly nowadays all the buildings, they have already transformed from bricks and walls to become glasses nowadays. So whenever we are transforming from bricks to glasses, so it looks more elegant, and it looks more beautiful nowadays. So, but we have other problems which is arising over here. That is due to the water spots. Okay, so and due to these water spots, we have to do regular cleaning on the building glasses. Okay, so when we are doing the cleaning, okay, we can see the jobs with most fatalities in Malaysia. This is been done by university. This survey is been done by University of Nottingham in Malaysia, and most of the workers, okay, this is the jobs of the most fatalities jobs. Okay, so this is motor vehicle operators, construction trade workers, material moving workers, law enforcement workers, agriculture workers, ground maintenance workers, sales and sales supervisors, vehicles and mobile equipment mechanics, supervisors, construction, metal and plastic workers. Okay, So the workplace death by industries in 2019, okay, it has been told that it has been done a survey. Is a construction death alone is 971 deaths. Okay, so that is very high. And even the dangerous jobs like cleaning a building glass comes under construction deaths as well. So how we can contribute to solve this problem is our self-cleaning hydrophobic coating. We have produced self-cleaning hydrophobic coating where we can do it can do a self-cleaning when it rains over there. And apart from that, we can also create an anti-fogging glass like the bare glass and the coated glass you can see. So this is powered by hydrophobic PDMS technology. PDMS means polydimethyl siloxane technology. So first thing, when we are talking about skyscrapers, okay? So the water spot on skyscrapers, so rainwater causes water spots, heavy rainfall, high humidity causes dust accumulations, hampers the transparency of the glass panel and reduce the visibility, and corrosion on the glass frame due to the presence of dust and water. So when we are talking about the cleaning of the skyscrapers, that is a second problem. Okay, the skyscrapers will be washed. The skyscrapers will be washed twice a year, sometimes 4 times in a year. So it requires 4 to 10 weeks to clean all the window glass of skyscrapers. Risky job as it deals with safety issues to clean the window glass. Fierce wind causes tool to be dropped and blows away the cleaners. So mostly these skyscraper cleaners, they use either gondola techniques or they use Spider-Man techniques to go on to do the cleaning. Okay. And then next is the lifespan of the building glass. So the wear such as sand grains, prolonged UV exposures, and harsh rainfall. Wearing causes cracks and reduced durability of the glass surface. Harsh cleaning using brush, robots, or detergent creates micro cracks, and acids from detergent can cause translucent and rough surfaces. Okay. So these are the problem statements. So when we talk about problems of the prior arts, okay, from our previous studies, okay, what most of the chemicals they contain fluoroalkyl silane, okay, where it is harmful and expensive chemical, poor transparency, translucent surface when incorporated with solvent, not in eco-friendly category, toxic and flammable. Okay, so this is where the technology readiness of ours comes in, where we are already gone into TRL 8, where we are ready to commercialization. So this is the novelty. First of all, is fast drying. It can be cured at room temperature within 15 to 20 minutes after spray on the PV panel or on any glass panels. Okay, it doesn't require any heat treatment in order to dry the coating or to cure the coating. Number 2, high transparency. The transparency of the coating is usually about 90 to 98% in UV visible region, and coating can absorb maximum solar irradiation for glass panel applications. Number 3, it is anti-fog, where you can see the bare glass and coated glass. The bare glass has fogging effect, and the coated glass with the coating, it doesn't show any kind of fogging effect, and it diminish away. Next is when we are talking about the coating on any glass panels, we have to talk about the addition of the coating. So with bare glass, the bare glass can get a scratch. Okay, we can see the scratch on bare glass. Okay, with 2.5 Newton of load, it can cause us a large cracks. Whereas with our coating with 2.5 Newton, there's no coating delamination. Actually, we have already done up to 5 Newton. We have already increased the hardness, I mean, the scratch hardness up to 5 Newton, and there is no coating delamination is been observed, and we have published. So this is the product description. This is the construction building glass. We can see, like on the non-coated building glasses, we can see the water streaks, okay? And on the coated one, we can see there is no water streak. So the coated panels on my right-hand side over here, we can see that there is no dirt streak. And with non-coated, we can see dirt streak on it, okay? This shows that the self-cleaning performance. We have also done our coating on the solar panel. Basically, for solar panels, okay, on top of the solar panel, usually it is a glass, okay? And with bare glass, okay, the transmissions, the transmittance is about 96, okay, is about 97 to 98. And with our coated glass, it shows roughly the same, is up to 98%. And the pictures of A, B, C, A, B, E, and D, this shows that, okay, over here, how is the rainfall, okay, affecting on it. So from here, we can see that there is no effect, okay. The S2 over here, it shows that the effect of the rainfall doesn't degrade the coating on top of the panels. So the bare glass, we can see that 2.5 Newton, it can show the delamination. So no failures on the coated and no failures up to 4 Newton as well, okay, for the coated panels. So this is the prior art, means we have done on the patent search on other patents which has been we have seen, okay. And this is our proposed patent, our patents, okay. So from here, our method is it's dry at ambient temperature, dust and liquid dirt, self-cleaning it can do. Our water contact angle is about 110 degrees. And our fabrication is very simple, either spray or dip coating, and very economic because we are using PDMS, Silgat, and absolute ethanol over here. Okay, compared to other prior art. So this is our market potential, market competitiveness over here. So our coating, okay, the coating which we have produced, it is optical transparent, number one. Number two, the water contact angle is 110 degrees. So it is near to super hydrophobic. Fabrication is very simple, is spray method only. Curing time is 15 to 20 minutes. Lifespan 3 years, sorry, lifespan is 3 years. And price per liter is RM 52 ringgit. Okay, that is Malaysian ringgit is 52 compared to other coatings which is available like Balco Nano, Dried Wire, Nano Life, and Nano Man. So this is the price of raw materials per kg hours, okay? And this market value is very, very important in order for us to bring into commercialization. So our total selling price compared to others is only 52 ringgit. And this is the comparative price for proposed novelty. Ours is, we have our coating, it consists of hydrophobic layer of polydimethyl siloxane, which has intrinsic flexibility of siloxane backbone and compact with methyl groups, which creates lower surface attraction against dust, dirt particles, and fogging droplets. So the binder we are using is Silgat, which cross-links with polydimethyl siloxane that construct elastic surface and strong adhesion to the glass substrate. And the ethanol solvent we use for this prototype are cheap and abundant. Ethanol is easy evaporation, transparent, and exhibit more compatible with PDMS glass substrate and did not tearing PDMS from the glass. Okay, so over here, apart from that, what we are putting in is we are putting above is nano calcium carbonate. Now the binders we are using PDMS and Silgat, but on top of it we are putting nano calcium carbonate over here, where this nano calcium carbonate creates a what we call air packs, okay, air pockets over here, that these air pockets can repel the waters to be not to stick on the surface. With this method, either rolling or via sliding off, it can remove the dust particles away. Okay, and this strategy is used to increase the product hardness, improve and what we call the rainfall impact test, we can see that with 50 increases the improve the hardness over here. So this is the commercial viability of the our self-cleaning coating. First thing is a proof of concept, where this high self-cleaning performance of coating is engineered by interaction between PDMS dispersions and Silgat resin binder. And when PDMS and Silgat is in contact with polar dirt, it quickly detaches itself to the dirt surface. Next, the evaluations. The performance of the coating can be evaluated via water contact angle test, UV spectroscopy, self-cleaning test, anti-fog test, and real outdoor testing. And we have already done the what we call by the evaluation bodies, which is in Malaysia. We call it as SERIM, and we have already done the tests from them. And the upscaling is the self-cleaning coating can be constructed onto large modules through simple spraying process and left at dry ambient temperatures. Okay, so the commercial viability is very huge, where it has a simple construction process, high transparent, fast curing, and reduced costs. So this is the real outdoor test which we have already done, okay, where we have coated on glass panels, and we have done the contact angle test above that, okay, and also we have done transmittance tests, UV resistance transmittance tests. From here, the transmittance, our coated panels, okay, is it is from 87 to 97% is that, and the coated glass with water contact angle, ours is still before and after outdoor is roughly the same, and the degradation is only 2.08%, we can see. So this we have done for what we call on the bare PV panels, okay. So with the bare PV panels, okay, with the photovoltaic panels and the coated photovoltaic panels, we have already done. This is the data for up to 3 weeks of tests we have done. For up to 3 weeks test, we have seen the degradation rate is about 5.36% for the bare PV panel, whereas with coated PV panels, 1.72%. But we have already done up to 6 months of test, okay, on the outdoor, okay, with coated PV panel with our coating, the degradation is only about 2.7% only, compared to the bare PV panels, it goes up to 20% of the degradation rate. So this is the self-cleaning performance against the dirt and solution. I can show this, okay. This is a small video. So this is, we are putting a mud solution on top of the bare panel and the coated glass. We can see the coated glass, it doesn't create, it doesn't have any dirt streak. So when we washed off, Okay. So the bare glass, there is the dirt streak over there, where the coated glass, there is no dirt streaks. So the benefits of it is, number one, the implementations of the construction building glass can prevent formation of water spots on construction building glass, number one, reduce labor costs and maintenance costs to clean high-rise building glasses. For UV light protections, PDMS polymer offer high UV protections after prolonged solar irradiations than commercialized synthetic polymers, less degradation and longer working time in real outdoor environment. Number two is cheap materials, where the materials that will be used for hydrophobic fabrication costings is about $12 per liter, which is relatively cheaper available market product, which are more costly, more used commercialized synthetic polymers. They use about, the cost is about $30 per liter. So this is the statistical evaluations which we got it from customers or from the public around us in Malaysia. Okay. And most of them, they want a better technology like this technology in order to put on the solar panel or on the glass panels. Okay. So this is the preferences of the applied on the glass panels, where all of the above is about 70.5%. They have already declared it. Okay. And these are the publications which we have published about our work over there for solar panels, and also on real outdoor applications on transparent self-cleaning coating for modified polydimethyl siloxane on real outdoor applications. And these are the first filings. We have filed a patent in Malaysia, and these are the awards which we won. Okay, and this is our industrial partners who have taking over our products for applications. Okay, and this is our business partners, and also our international business partners purchasing our products for their applications. Okay. And next is our conference. We are organizing a conference in Malaysia. Okay. That is a sixth international conference on clean energy and technology, together with international symposium on electric mobility. So you can always come to our website to check. Okay. And it is done on hybrid mode on our conference, and you can come to our website and register over here and submit the papers. Okay, and you can also become our co-organizers over here. Okay, so for the lodging, for the accommodations and all that, these are the links we have provided in our website itself, and that is our email for our conference. You can always communicate to us. Either it can be physical or on virtual basis. Thank you. Thank you. That's all from me. Any question from the floor?
Thank you so much, sir.
Yes.
Yes, from participant side, if you have any question, you may ask to sir. Thank you so much, Dr. Balakrishnan, sir, for this great informative session.
Thank you.
If participants have any question, they may put their question in chat box also. I think no question is here. Thank you so much, sir. So now it's time to move towards the next session. And for this session, it's my pleasure to introduce Professor Helen P. Kavitha. She obtained her PhD in chemistry from Bharatidasan University, Tiruchirappalli. Presently, she is heading the Department of Chemistry, SRM Institute of Science and Technology, Ramapuram campus. She also had administrative experience as the program coordinator for part-time program and chief superintendent of examinations in SRM Ramapuram campus. She has more than 2 decades of experience in teaching and research. She has presented more than 100 papers in various national and international conferences and published 60 papers in peer-reviewed journals. Her field of expertise is organic synthesis, nanomaterial synthesis for energy and environmental applications, environmental chemistry, and computational chemistry. Dr. Helen is guiding scholar for PhD program. She is the reviewer for many international journals. She has authored 5 books in chemistry and had carried out 3 minor projects as principal investigator sponsored by SRMIST. To promote the scientific interest in the students and motivate faculty members to achieve excellence in the academic career, she organizes various national and international programs at regular interval of time. Dr. Helen was nominated to visit the University of Mauritius under UGC Tech in year 2021. She visited countries like Malaysia, Singapore, etc. She is the life member in ISTE, ICCE, and ISCAS. She is the Board of Studies member and doctorate committee member in various reputed organizations. She is the Vice President in Association of Chemistry Teacher Mumbai and Society for Advertisement in Chemical Sciences and Education. She is the recipient of Best Woman Chemistry Teacher Award for the year 2019, award by Association of Chemistry Teacher Mumbai. So I request Professor Helen Kavitha ma'am to start her session. It's over to you, ma'am.
Thank you so much, Doctor, for your nice introduction. A very good evening to one and all connected here for this online session. At the outset, I would like to thank the organizers of the Kamala Nehru Mahavidyalaya Nagpur and Association of Chemistry Teacher and Jagat Arts, Commerce and IHP Science College, Gondia, for giving me an opportunity to share my thoughts in this August gathering during the occasion of Global Women Breakfast 2023. And I would like to have a special mention and thanks to Dr. Vasudev Gurnale sir for inviting me for this session. And it is a flagship event of ACT, and I am very proud and honored to be a part of this program. And today I'll be talking about fostering towards unequal science. I hope the previous speaker was talking about a very good research work. My talk will be general on how women are progressing in science. So let me share my slides. Is my slide visible, sir?
Yes, ma'am.
Yeah. So I would like to start my presentation by quoting a famous poem of Mahakavi Subramania Bharatiyar, a great legendary Tamil poet, whose poems I always used to memorize when I was in a childhood, when I'm going for any competitions, any speech competitions. He says like that, பட்டங்கள் ஆழ்வதும் சட்டங்கள் செய்வதும் காரினில் பெண்கள் நடத்த வந்தோம் எட்டு மறிவினில் ஆணுக்கிங்கே பெண் இளப்பிள்ளை காணென்று புண்ணியடி. What is the meaning? We the women have come to rule scholastically and create the law for this world. Clap and rejoice, for the women are no less than men in reaching the heights of the knowledge. So what is a knowledgeable society? A knowledgeable society is one which empowers all the members of the society. Only if it empowers all the members of the society, there will be economic development, there will be cultural development, there will be social development, and there will be scientific and technological development. And we know that women constitute 50% of this world population, of this human population. That is, the half of the human resource of the country are women. And if this half of this population is not given proper place or not nurtured properly, then there will not be any social, economic, or scientific and technological development. And when we talk about the education of the women in the past, during the early Vedic period, only few women, prominent women were there in science. And during the medieval period, the political and social transformation has lowered the status of women, and they were restricted from getting education. Only in the late 18th century, education was opened up for women, and many women have broken the glass ceilings and achieved their respective fields. And in the 19th century, many social reforms have happened, and many women have into education, and there is participation of girls at all stages of education has been increasing through the years. And there is a saying, when you educate a man, you educate a man. But when you educate a woman, you educate a generation. And this is a photograph, this photograph is called as the most intelligent photo ever taken in the human history. And this photograph is taken in 1927 Solvay Council Conference. And you can see many famous scientists like Einstein, Bohr, Curie, Heisenberg, Schrödinger were seen to be seen in the photograph. And out of the 29 attendees who attended this Solvay conference, there is only one female scientist who is sitting among 28 men scientists. When I was just pondering into this photograph, I was just thinking how Marie Curie was able to make her position in this place, in this photograph. What made her to strive towards achieving this position, or what is the passion she was having for reaching this position? And when you read the life history of Madame Curie, it was very interesting, and also you could find the passion that she had for making a new science. And she had got many sleepless nights for achieving what she has achieved. And we know that she has obtained Nobel Prize twice, one for physics and chemistry. And how she is able to get it, how she is able to get 2 Nobel Prize, and how she was able to be successful as a Nobel scientist. She says that we must have perseverance and above all confidence in ourselves. And we must feel that we are gifted for something and that this thing must be attained. And also she's saying that it is her earnest desire that some of women should carry this scientific work to get ambition, the determination to get a permanent contribution to science. And it is always thought that science or masculine, only boy and men can do it, arts are feminine. And the technical skills are always manly, and it is a boy activity, and women cannot do it. But all this taboo has been broken in many women, even in the past. And recently, many of the women scientists, they are into various fields. They have ventured into all walks of life. In all fields, they are into it. They are piloting the aircraft, or being an industrialist. They are scientists. They are doctors. They are engineers. In all positions, women are occupying the roles now. And we cannot talk about science without talking about the notable contribution by some of the women scientists of the past. And these are the women scientists who have contributed a lot in spite of the hardships when education was not given to women. And we know the contribution of Ashima Chatterjee in organic chemistry. She has got a cure for this epilepsy. And the contribution of Komala Sahani, she is a biochemist, and she is the first woman to receive PhD in biochemistry. And we know Darshan Ranganathan is a very famous organic chemist. When education was not provided to women, she has obtained her PhD. Not only obtaining her PhD, she went to London for getting the postdoctoral fellowship. And even we know the contribution of Saraswati Amma, a great mathematician, and Janaki Amma, a scientist. And now many women, all the bondages of the past has been broken by women now. And we are given a lot of freedom. We are into every field. Higher education, we are getting higher education, we are getting higher training. Even in employment opportunities, we are all given equal grade. And more women scientists are surfacing and they are contributing to the scientific community. And even we have stuck with the COVID pandemic for the past 13 to 3 years. And during that period, these 4 women scientists, there are many scientists who are working for this to fight against COVID, but these 4 women scientists are in the forefront for finding the vaccine against the COVID-19. Dr. Priya Abraham, she's the director of National Institute of Virology, Pune, and she was instrumental and she was leading a team which is working on getting the Covaxin vaccine. And Dr. Padmapriya, she is the director of National Institute of Research, Chennai. She was leading the team and she was the leader for the group of scientists who are into COVID preparation of Covishield, and they were instrumental in the phase 2 and phase 3 human trials. And we know the contribution of Pragya, and she is the head biosafety center. And she was working with preparing antibodies for SARS-CoV. And Nivedita Gupta, she is the head of virology ICMR New Delhi, and she is instrumental in getting the COVID kit. So now more number of women are contributing a lot to the science field and to the society. And every year, Nature, which is one of the most leading multinational global journal, which is awarding the scientists who are contributing, making a prominent contribution in science. And in the 2022 award Nature Award was received by Kesmikia Corbett. She is a professor from immunology and infectious diseases, and she was awarded this one for the development of Moderna COVID-19. And the 2021 Nature Award was received by Dr. Kayana Oren. She is the associate professor from Tech Graduate Institute, and she was working on nanobiosensors for healthcare applications. And Samira received the Nature Award in 2020, a computational biologist for her genomic research. Not only that, now Government of India is also encouraging women scientists who are doing a lot of contribution in science. And every year, DST SERB is awarding women scientists below the age of 40 who are doing remarkable work, and they are given funded of 5 lakh rupees every year for a period of 3 years. And last year in 2022 also, 9 women scientists have been awarded SERB Women Excellence Award, and I have mentioned few of them here. Dr. Chandini, Assistant Professor, Department of Instrumentation and Applied Physics, IIC, and she is working on the research of 2-dimensional materials and heterostructures as sensors. And Dr. Bikina Patak, she is also the Assistant Professor from Dibgrad University, and she is working on studying Earth's climate, atmosphere and climate. And Nikita is also the proud recipient of SERB Excellence Women Award 2022. Women are now venturing into every field. What is required is women just to need to be willing. And if any opportunity comes to that, they have to grab the opportunity and they have to explore the opportunities. With the knowledge explosion, sky is not the limit, and there is much beyond it. And we know the contribution of Tessie Thomas, a missile woman of India. And she is the first woman scientist to head the missile project in India. And she is the Director General of Aeronautical Systems and the former project director of Agni Missile. She is the proud recipient of Agni Self-Reliance Award in 2001, and she is the recipient of multiple fellowships and honorary doctorates from various prestigious institutions. We must acknowledge and appreciate the work done by Kuljit Kaur Marhas, and she is the award-winning planetary scientist. Her research is based on where do the elements come that form the universe. Currently, she is the recipient of several awards by Department of Science and Technology. She received Women Excellence Award in 2013, And she's also a recipient of Devendra Lal Memorial Medal in San Francisco in 2019 for her groundbreaking discoveries in earth and space sciences. And it is worthy to note that she is professionally the only person working on experimental indirect astronomy of our country. Ritu Karidal is called as the Rocket Woman of India, and she was the Deputy Director, the Operations Director to India's Mars Orbit Mission, Mangalyaan. And she received the ISRO Young Scientist Award from our then former President of APJ Abdul Kalam sir. Nandini Harinath is a prominent name among the women scientists. She served as the Deputy Operations Director on the Mars Orbit Mission Mangalyaan. And she had 20 years of experience at ISRO. In her 20 years of experience in ISRO, she worked in 14 missions. And she is really a true inspiring scientist for the young generation. Utaya Vanita is again a very inspiring scientist, and she is an electronic engineer from the College of Engineering, Gindi, Chennai. And she is the project director of Chandrayaan-2. She worked in many capacities as in ISRO, as a telemetry and telecommand divisions in digital systems. And in 2006, she has received Best Women Scientist Award. And this scientist is really worthy to note, the polar women of ISRO. We can't imagine a lady at the age of 56 going and staying in a polar region like Antarctica for a year, for more than a year. And she, when it was assigned to her, she took over the job courageously. And she, with a team of 23 members, went on to the expedition to Bharati, India's research station in Antarctica. She was staying there for 403 days, and she was taking care of operating and maintaining ISRO's ground station. Really a very inspiring, truly an inspiring scientist of our time. Raju Arasu, she is the Vice President of INTUBE, and she's really the inspiration for young women who wanted to take up their career. And similarly, the contribution of Kamakshi Sivaramakrishnan is also brilliant, and she is working with NASA's New Horizon mission, which is probing Pluto, the farthest space mission. Mallika Srinivasan is again a very inspiring lady. And Aditi Pant, she is a successful oceanographer, and she is the first woman to visit Antarctica in 1983, and she got US government scholarship, and she worked at the National Institute of Oceanography and National Laboratory. And Chandrika Shaha, the famous and a very proud woman, a biologist and the first woman president of Indian National Academy, INSA. Until she taken over as the director, in its existence of 85 years, Academy has never had a director, and the president, Shilpi, take over. And she has received Shakuntala Amarchand Award in 1992, and for a remarkable contribution to understanding the cell death in different organisms, she has been awarded a special award on the 50th anniversary of DNA double helix discovery. And she was elected as a vice president between 2016 and 18 in INSA. She is a real inspiring scientist for the future scientist. Ganga Dev is a virologist and a scientist, and she is the first woman scientist to be elected as a fellow of Royal Society, and she is the chairperson of World Health Organization. Sita Koliman, she is a chemist, an environmentalist, and an entrepreneur. Actually, she was working in a royal dead shell, and she became the head of the Department of Plastic Manufacturing Industry. She was instrumental, and she was making a lot of plastic models and plastic materials. When she visited India, she observed and she was able to find out the bad effect of these plastics because of non-degradable plastics. So it was just worrying her how to, because she was there as a head in the plastic division, so she was worrying much. And when she visited India, she established a concern called as Simply Sustain. And this company is about focusing on industrial ecology and assessment of the life cycle of the products. Before a plastic could be formed, they will assess what is the life cycle of the product. And a very groundbreaking cancer biologist is Bushra Atiq. And she has received many awards like Sun Pharma Science Foundation Research in 2021. And she is featured in Indian Women in Science 2020, 2021 by Life Sciences. And similarly, Parimala Raman, she is the one of the 11 chairs have been in the name of women scientists, and she is the only living person on the list. And similarly, Neeta Gupta, she is the third and the fourth women to receive the prestigious DST award, Ramanujam Prize. And so much I've said about the contribution of women scientists in different fields. When you just look at the statistics, when I think there is some disturbance. Can you just mute the phones?
Ekta Yadav, you please mute your mic. Ekta Yadav. Yes, thank you.
Okay, thank you. Having said about the important contributions made by various women scientists, but still the progress of women in science is in a slower phase. When it comes to undergraduate program, PG program and MPhil, it is okay to some extent. But when it comes to doctoral program and postdoctoral program, the number of women taking the doctoral and postdoctoral positions are less when compared to men. There is a gap that exists between the number of enrollment of women in science as well as the number of enrollment of men in science. And this is a recent report that was released by DST. When we see the overall percentage of women, and regarding the national figure, there are about women principal investigators in research and development. In 2001, there were only 232 principal investigators. But when we look at the data in 2016 and 17, it is 4 times increase. The number of principal investigators have increased from 232 to 941, which is 4 times, which is a welcoming sign in the case of women taking as a PI. When you talk about the number of women researchers in India, it is almost doubled from 2014 to 2022. We have only 30,000 women researchers in 2014, whereas in 2022, we are having 60,000 women researchers in India. And when we consider the participation of women, women participation in biotechnology research is the highest, which constitute about 40%, and in medicine it is 35%. Specifically, when you talk about the Department of Science and Technology, and it is observed that out of 97 scientists in the Department of Science and Technology, 35 scientists are women. And the big achievement is that out of 11 out of 18 divisions of DST are now headed by women. It is really a very welcoming sight. That is almost 50%, more than 50%, almost 61% of the division, of 61% of women are heading the divisions of DST. And this is the largest percentage of women in leadership in any government department. And this is a very welcoming sign, and it is a proud moment that 11 chairs, STEM chairs, have been named after the famous scientists. Janaki Ammal, Darshan Ranganathan, Ashima Chatterjee, Dr. Anna Mani, Rajeshwari Chatterjee, Raman Parimala, Kadambari Ganguly, and so on. When we look at the percentage of women, occupation of women in STEM field, it is a global average that 46% of occupation, biological sciences, women are occupied in biological sciences. There is 40% in chemical and material sciences, and it is 25% in computer and mathematical occupation, and 16.5% occupation for engineers and architects. And when we talk about the participation of women globally, it is the data gives the number is less, but still 52% of college educated workforce globally are women, and 8% of global enrollment of girls in manufacturing and construction engineering is 8%, and in mathematics and statistics the global percentage is only 5% of women. Yale scientific study says that 25% of women are in scientific education materials in 2016. UNESCO report says that 29.3% of researchers are worldwide are women, and only 19.2% of women are in board positions related to STEM industry. This is the report taken by MSCI, and it is worrying to know that only 3% of women CEOs are there in the STEM industry. And this is a gray area where women have to really look into it, and the society needs a concern on these issues. And participation of women in national science academies. There's an association called as Gender in Science, Innovation, Technology and Engineering. And this, in collaboration with the Inter-Academy Partnership and International Science Council, they have conducted a survey in 2021. And over 120 national science academies, and they have participated in this survey. And the report of the survey states that the representation of women across various countries is found to be less. And this is the data which is taken for the participation of women in national academies. We can see that in USA, the participation is only 13%. Even in countries like USA, it is 13%. Australia, it is 15%. And Brazil, it is 15%. Canada, it is 25%. And Mexico, it is 25%. You see the percentage of women in National Academy of Sciences in India. It is only 6% in 2015. And in 2020, it is only 9%. It is again a gray area in which women scientists have really looked into it. And this is the percentage of participation in national science academies. Again, the data is not encouraging across the countries. As I have pointed out in the previous slides, the number of women who have opted for science technology is growing in the undergraduate level, postgraduate level. And it is a very, very happy moment to share that India ranks 43% STEM graduates are there in India as women, and this is the highest number in the world at the tertiary level. When you just compare the data with other countries, India ranks the 43%. It is the highest among Italy, France it is 32%, Italy it is 39.5, Canada it is 31.4, and India ranks 43 in tertiary level of education. But a question arises, there is a big question mark, but only 14% of women are there in the occupation or 43% of women are educated and only 14% are opting for job. What happens to the remaining percentage? Where are the female graduates, the women graduates have gone? What is happening? There are two major issues that stand out in lagging the progress of the women. Two issues are, one related to the entry and retention of women in science, and the other related to the differences in the career attainment among the female and the male scientists. Normally, up to PG level, up to PhD, when you even for entering into PhD, the number of women entering into PhD is less when compared to number of men entering into PhD. But when you come to occupation, the job opportunity comes only after completing their PhD. But this is the age which coincides exactly with the age where women have to get married and settle in life. They cannot proceed, they cannot prolong further because already it is late. So they wanted to settle in life. They wanted to get married and settle in life. Because they are taking a break in their career for 3 to 5 years. So their entry is lagging. Whereas a man who has got PhD, he will get into job and their career will progress. And even number of women graduates who are going into postdoc is less. Sometimes after getting a PhD, men will go for postdoc, whereas women cannot go for postdoc because of the social responsibilities, family responsibilities. So therefore, a gap exists between the contribution of in terms of publication. Even there is, I'm not having, I have data regarding the gap in the publication between men and women. There is gap in the patent filing. There is gap in research funding. There is a lot of gap that is existing between women and men because of this. Because of this gap that is existing between the science, female scientists and the male scientists, the entry and retention of women in science is becoming less. Women are not promoted to higher level because when you go for any academic institution, they will see your profile, they will check for your IAPI. So if the women are not getting good number of publications, citations, everything, their promotion is also restricted. So there is a gap that is existing in the entry level as well as retention. Because of that, women, there is a lot of career difference between men and women occupying the higher leadership roles or higher positions in academia or any institution is lagging behind. But what to do? Women have to carry out that role. You cannot say, I don't want to get married, I don't want social responsibilities or home responsibilities. We want it. But now we have achieved these many ladies, what I am telling about ladies and even myself, we have achieved, we have come so far with all these responsibilities. We have determination and we have to go a long way. And we know, and as a ladies, since opportunities are given to us, we know how to grab the opportunity to bridge the gap or close the gap. You know, Indian Institute of IIT Bombay, there are only 25 professors out of 143 professors. Out of 143 professors, only 25 are women. And in IIT Madras also, out of 304 professors, only 31 are women or professors, which contribute only to 10.2%. And to date, none of the IITs or any prestigious institutions like IISc Bangalore or Tata Institute of Fundamental Research is having a women director. And even in IIT Madras, 3 out of 53 chairs are held by women. And even in IISc, just 1 out of 9 chairs are held by women scientists. Even in ISRO, there are only few scientists. And even in administration, women employees in administration are 17.6% in ISRO. And women are also not recognized when for the scientific achievements. In some cases, case studies are there, especially with respect to Young Scientist Award and National Bioscience Awards. There is low participation of women in science. Women, there is a gap in science. Why there is a low participation of women? Stereotyping. We say that men are capable of doing this. They can do science. Can't women do science? Yes, women can do science. It is not about who can do science. Who is passionate about science can do science. And patriarchal thought process, even educated women, educated men are thinking that these roles are not required for girls. So let us be comfortable and let us not take it. That will be very challenging and let us not do it. And societal norms is also disturbing us. Unnecessary fear about the competent qualities and stress related to childbirth and marriage. When any woman is concentrating more on her profession, then people will say that she's more into profession and she's not bothered about home. And there is a sort of guilt feeling that comes to us that we are not taking care of the child. And if we are taking care of the child alone, then our profession growth will go off. There is a lot of stress that is in the women related to social responsibilities, household responsibilities, physical safety, harassment. In many places, harassments are happening, but we have to really look into it. So how to bridge the gap? How to bridge the gap? Raise awareness among the girls. And I strongly advocate and I feel that we have to raise the girls and boys as an equal thing. Even at home, they have to be treated properly. Even in assigning any work as a mother or a father, we should say that this work is for you and this work is for life. There is nothing like that. It is a household work everybody has to do. If your daughter is mopping, you ask her son to sweep. There is nothing wrong in it because everybody has to grow and you are equal. And if that thought process is inculcated into the mind of a growing child, even as a small kid, then that is going to definitely change the thought process about the men and the women in the society. And girls should be, we always want the girls to be very beautiful, very pretty, and they wanted to be play a very safe role. But it is not required. You just give them courage. Tell them that you are bold. You are able to do anything. So that sort of mindset should be created in the home itself. And give girls a confidence and give them freedom of their own choices. And let them select the courses they wanted to offer. Let them select the job they wanted to go. Have confidence and give choices for them. Promote awareness among the parents. Show visible models. Normally, girls are very fascinated to look into the models. Models in the sense, the people who really inspire us. So when I see some iconic ladies, I always try to read their biographies and tell how this person is able to reach that position. To give a lot of role models to girls who will really take it and come up with their career. Provide age relaxation and accommodate career breaks. If there is a break in the career, and if you consider for any higher positions or academic ladder, for next level of academic ladder, consider this career breaks also. Improve job hiring, more number of women have to be recruited, and give professional development to the women and promote a welcoming work environment. So what are the initiatives? I'll just finish it in 5 minutes. There are various initiatives taken by Government of India. One is like Vijnan Jyoti scheme, and this scheme is about for the girl students to pursue who are doing well in the higher secondary to pursue science as a career, STEM in the higher education, and that is a Gati scheme. And we have a scheme called as Knowledge Involvement Research Advancement through Nurturing. There's a current scheme. And this scheme is for the women scientists who are unemployed scientists. They can take up even after the break. And around 2,200 women scientists and technologists have been benefited through this scheme. And there is another program called as Mobility. This is the program for the women who are having the issue of relocation. So they can go abroad and you can study in a premier institution and come back. There is another scheme called as Curie consolidation, and this is for the women-only universities for developing the infrastructure. And now DST is insisting on having more number of women in leadership positions. And DST insists when they wanted to grade the institutions, they see that 30% of women are there in the decision-making roles. All those efforts taken by Government of India is really welcoming, and more women will be surfacing, and they'll be doing a lot of contribution to science. And we have other DST programs. Every year 1,000 fellowships are given, and for the basic and applied sciences, and for postdoctoral researchers also for the age of 27 to 32, scholarships are given in applied sciences area. And during the International Day of Women's Child, girls are across the country are honored with many awards and medals in science and mathematics. So I have come to the conclusion of my speech. Having said all this, we have to, every girl who is born in this world has to achieve something. If they have a real passion for science, they have to chase their dream and they have to achieve it. Don't let anyone rob of your imagination, your creativity. When somebody says that you are not able to do it, you cannot do it, don't believe them. You believe in yourself. Your creativity or your curiosity, it is your place in the world. It is your life. Go on and do all you can with it and make it the life you want to live. And for this journey, I don't say that the contribution of men is not required. We have to go along with them. I need, in my journey, in our journey, in a long journey, we have to have our husband with us, our daughter, our father, and our brother, to hold our hands and say that come, let us walk. To pat on our shoulders and say that you can do it. And to hug and say that you are in terms of when we are in distress, to say that you can do it, no problem. And the distance women have traveled is so long for reaching this position, and we have a long way to reach to get equality in science. So let us not let anyone rob our dreams, and let us achieve what we really want to achieve. Thank you again. And there is no force equal to women who is determined to rise. A strong woman stands up for herself, and a stronger woman stands up for everyone. Thank you so much for giving an opportunity to share my thoughts on this wonderful occasion of Global Women Breakfast 2023. Once again, thank Gurnale sir for the nice opportunity that is given to me. Thank you so much.
Thank you so much, ma'am, for building up confidence among women. It's really very nice session, and it's great to see the past team women achievers and how women are progressing, how women scientists are progressing, but still have less participants, women participants in STEM. So it's a great session, great information. Thank you so much, ma'am. Now I request Dr. W.B. Gurnale sir to propose vote of thanks.
Okay. Hello, Madam, Helen, Madam.
Yes, yes, sir.
Thank you for your nice presentation. Okay.
Thank you, sir.
Madam, stop the sharing. Okay.
Yes, stop sharing.
Yeah,
No, I
yeah.
won't say. One second.
Thank you, Rashmi. International webinar, IUPAC Global One Breakfast 2023, which is on the breaking barrier in science, organized by the Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur, in association with ACT, Mumbai, and Jagat College of Arts, Commerce and Science, Goregaon. Here, first I would like to thank Honorable Dr. Suhasini Vanjari Madam, President of Amar Seva Mandal, and Honorable Advocate Abhijit Vanjari Sir, MLC and Secretary of Amar Seva Mandal, Nagpur, and Doctors Honorable Smita Vanjari Madam, Treasurer of Amar Seva Mandal, who is a source of inspiration for us. So I'm thankful to them. I also thanks Shri Jagatramji Rangdale, President of Bahujan Hitai Jagat Sanstha, Goregaon, for the cooperation and for the inspiration for us for organization of such type of webinar. I also would like to thank respected Professor Brijesh Parisar, President of Association of Chemistry Teacher, for kind support in organization and this webinar and accepting our invitation to preside over this inauguration session of this international webinar and as a chief guest for this webinar. I also express my thanks to Principal of our college, Dr. D.S. Badwaik sir, Dr. Lanjewar sir, Principal of Jagat College, Goregaon, for guiding us from time to time to make this webinar a grand success. I also express my thanks to Dr. S.S. Rangdale, co-convener, for cooperation and wonderful organization. And I am personally and on behalf of organizing committee thankful to resource person Professor Sonia Carabiro from the Nova University of Lisbon, Portugal, Dr. Balakrishnan from University of Malaya, Malaysia, and Professor Helen Kavita from ESAB University, Chennai, India, for their wonderful and excellent presentation they have given today. The presentation was very excellent and informative and definitely useful to all the participants. I am also thankful to all the participants from the various states of India and also from 20 different countries for their warm response to this international webinar. All the staff members of organizing institute need to be thanked because they did not leave unturned to make this webinar a grand success. And especially I thanks Dr. Lanjewar, Dr. Rashmi Dubey, and Vice Principal of Jagat College, Dr. Bairam sir. I give thanks to all those who have helped us directly or indirectly to make this webinar a grand success. So, once again, thank you. Thank you. Before ending this webinar, all the participants are requested to switch on their video so that we can take the group photograph.
यूनिवर्सिटी कॉलेज
You can't win argument verified until you.
Hello, participants are requested to switch on their video so that we can take the photograph.
You have to create something.
అది రీపో అట్లా పడేస్తే
Hello, Rashmi, over to
Yes,
you.
sir.
Okay, thank you to all
Yes, sir.
participants. Yeah.
Yes. All participants are informed that the feedback link will be given in the respective group as well as in the chat box. So all of you are requested to fill the feedback form. The link will be given in the chat box as well as in the respective groups.
Hello, ma'am.
Yes, sir.
Student of MSc Organics Chemistry.
Yes.
क्या पार्टिसिपेट्स को कुछ सर्टिफिकेट प्रोवाइड मिलेगा? हेलो मैम.
Gurnali sir, can I leave?
Yes, madam.
Thank you so much,
thank you.
Thank you
Thank you
so
for
much,
your
sir.
wonderful
Yeah.
presentation, madam. Yeah.
Thank you, sir. Thank you. I'll talk to you later. Thank you.
Yeah.
Hello, sir. Hello, sir.
हेलो
सर मेरा क्वेश्चन था.
हाँ या
सर जीपेट के थ्रू एमबीए कर सकते हैं क्या? जीपेट एग्जाम के थ्रू एमबीए कर सकते हैं क्या?
No, you have to ask to the office, okay na, about this.
सर जो एमफार्म के लिए जीपेट एग्जाम होती है,
हाँ
उसके थ्रू हम एमबीए कर सकते हैं क्या?
No, it is only for that na.
Only for एमफार्म.
Yes, pharmacy.
Okay, sir.